If I touch it, it would explode and destroy all of New York City, parts of Connecticut, and New Jersey. This is one of the greatest mysteries in all of physics.
Could the silence surrounding the world's largest particle physics laboratory, CERN, be the harbinger of unsettling events lurking just beyond the horizon? In a world where knowledge and exploration have become the bedrock of progress, the unexpected silence and recent shutdown of CERN raise countless questions about what may be unfolding behind closed doors. What exactly is happening at CERN, and why does its silence resonate so deeply? Join us as we embark on a journey into the enigmatic realm of CERN, where the silence speaks volumes and the unknown looms ominously. The famous Large Hadron Collider, LHC, at CERN, which is in Switzerland near Geneva, was closed for 3 years to get upgrades and repairs. It started working again in April 2022 for a new phase called Run 3. During this time, scientists will do amazing experiments that will get a lot of attention until 2024. However, CERN recently announced something unsettling about turning on the LHC. We will look into the possible dangers that this brings to our existence. Organizations like NASA, Tesla, and others are always interested in learning about our world. NASA and Tesla focus on exploring space, while CERN wants to uncover the mysteries of Earth and discover its hidden potential. CERN is famous as one of the biggest and most respected scientific research centers in the world. Scientists, physicists, and engineers at CERN collaborate to find answers to difficult scientific questions. They study various things like different dimensions, dark matter, and unproven theories. They use advanced tools that are beyond our imagination to help them in their research. CERN has made important discoveries like neutral currents, the Higgs boson, and the mysterious God particle. However, they still have a strong desire to learn more. One of their ongoing missions is to find magnetic monopoles. Magnetic monopoles are unique particles that possess only one kind of magnetic pole, either a north pole or a south pole. Unlike regular magnetic particles that have both poles, these special particles have just one. Although scientists think magnetic monopoles exist, they have been unable to locate them for 100 years. To find these particles, scientists constructed colliders. Scientists had high expectations that colliders would generate magnetic monopoles, but until now, none have been found. The LHC uses strong magnets to make a powerful magnetic field. Inside the LHC, there is a special coil that lets electricity flow without wasting much energy. The LHC is built underground, about 328 feet deep, with strong walls to block radiation from the Earth. Because of all these things, the LHC can create magnetic fields that are much stronger than Earth's magnetic field, about 1,000 times stronger. The LHC has lots of magnets set up in a certain pattern to control the particles' paths. It is like a big ring that is 27 kilometers long and made of special magnets that can conduct electricity very well. Some of these magnets are made to bend the particles' paths, and they are called dipole magnets. They are very heavy, weighing 35 tons each, and are 15 meters long. The Large Hadron Collider, LHC, is a cool machine that scientists use to understand the universe better. It shoots really small particles at super fast speeds, making it the most powerful collider in the whole world. When these particles crash into each other inside the LHC, scientists discover amazing new things about the universe. Everyone in the science community was really happy when the LHC finally started working after waiting for 3 years. It was built very carefully over a long time and has been a really important tool for studying science since it was created. Building the LHC was hard because scientists wanted to make particles collide with lots of energy inside it. By doing this, they can learn a whole bunch of stuff about the tiny particles that make up everything. Normally, particles collide in the air around Earth, but they break apart quickly, which makes them difficult to study directly. The LHC's long tunnel is the only place where scientists can effectively investigate these particles. The LHC was built between 1983 and 1988, and it cost a lot of money, around 7.5 billion euros or $9 billion. It is one of the most expensive scientific tools ever created. The LHC does experiments by making tiny particles crash into each other. It happens so fast that there are about 600 million collisions every second. All of these collisions create a huge amount of information, about 15 petabytes each year, which is the same as 1,000 terabytes. Looking through all of this data is a big challenge for the scientists at CERN, so scientists from different countries work together on the LHC. Although the LHC started working on September 10, 2008, there was a problem with some magnets that caused a delay of more than a year in the beginning. More than 50 special magnets and their parts got damaged. Finally, in 2010, the LHC had a big moment when it made protons and lead nuclei crash into each other at really high energies. This led to new and amazing scientific discoveries from 2010 to 2013. But the scientists at CERN realized that the super collider needed more improvements, so they continued working on it. In 2013, the Large Hadron Collider, LHC, had to temporarily stop working. It was then improved and started again in 2015, after a 2-year break called Long Shutdown 1-inch, or LS1. During this break, the organization operating the LHC, called CERN, made the LHC's accelerators and detectors better and replaced some magnetic systems. These improvements allowed the LHC to operate at its maximum power. So in 2015, the LHC started working again with improved abilities. In 2018, the LHC had another period of not working to make upgrades. The upgrades were aimed at increasing the LHC's luminosity. Luminosity means how often particles collide inside the LHC, and this is important for getting valuable information. CERN wanted to study monopoles and dark matter in more detail. Dark matter is a kind of material in space that doesn't absorb, reflect, or emit light. Because of this, it's not possible to detect it using normal methods. Scientists believe that dark matter was created shortly after the Big Bang. Understanding dark matter was a major goal for the improved LHC. However, something unexpected and very bad happened because of the experiments done at the Large Hadron Collider, LHC. The LHC is a machine that scientists use to study particles. When they turned it on again in April 2022 with more power, they discovered something shocking about Earth's magnetic field. The magnetic field is like a shield that protects us from dangerous solar winds, but the LHC found a strange crack in the magnetic field that had never been seen before. Normally, the magnetic field has a small gap at certain times, but this crack stayed open for a long time, 14 hours in a row. But to what effect is this unusual crack dangerous for Earth's magnetic field? It's important to understand that this crack doesn't let creatures from other dimensions or worlds come to Earth. The main job of the magnetic field is to protect us from the strong solar winds. These winds can cause big problems like damaging the ozone layer and affecting space activities, satellites, and power grids. This can lead to blackouts, where there is no electricity. NASA, the space agency, keeps a close watch on the Earth's magnetic field, and they have noticed it is getting weaker, especially in a place called the South Atlantic Anomaly. The magnetic field is very important for keeping things in balance on Earth, helping animals find their way, and keeping us safe from solar winds. Some people think that the experiments at the LHC might have made the magnetic field weaker, but we don't know for sure. If certain areas of the magnetic field become weak, it can be a danger to satellites and spacecraft in space. Our communication systems, like phones, radios, TVs, and the internet, rely on satellites. Solar flares, which are bursts of heat, light, and radiation from the sun, can disrupt these systems. They can also cause big eruptions on the sun's surface. These eruptions can lead to blackouts and problems with communication. NASA has warned that 2 very big solar flares are heading toward Earth, and they could cause problems with radio signals, satellite navigation, and even the global internet. In the past, similar events have shown how powerful solar storms can be, but they also create beautiful displays in the sky. Some people think that the LHC might have made the magnetic field weaker, which could have allowed solar winds to affect us. However, we don't have proof of this yet. Scientists and research organizations need to work together to reduce the risks of solar storms and keep people safe. And that's a wrap on our discussion about the silence and shutdown of CERN, which has left us all pondering the unsettling events that may be unfolding. So, what are your thoughts on this intriguing turn of events? Do you believe that CERN's silence and shutdown signify a larger shift in our understanding of the universe? Let us know in the comments. Thank you for joining us on this thought-provoking journey.